Hi everyone, it's Coach Fred here, and I'm going to be doing a formal lesson of what you investigated on Desmos today in class. We're working on the graphs of the quadratic function and Vertex form notes that you were taking at the end of class. And we're going to start on the second page. We're going to be graphing using translations. So this is the formal quadratic equation in Vertex form. It's in the form y equals a x minus h squared plus k. And today we learned about what a does to the parent graph of y equals x squared, how it compares, h, what it does to the graph, what k does. But we want to make sure we recognize this is vertex form, okay? And we want to recognize that our vertex is hk, okay? And this is the graph of a parabola. All right, so A does one of two things. So the absolute value of A, okay, so if we just look at the number regardless of the sign, if A is greater than 1, okay, then it's a vertical stretch. That means it gets narrower, gets pulled closer to the y-axis. That's what you guys figured out today. And if A is less than 1 but greater than 0, or actually the absolute value of A, that's what I really mean, is between 1 and 0. So it's a fraction smaller than 1. It's a vertical shrink. So shrinking away from the y-axis. So this one is going to look wider than the parent, and this one is going to look narrower than the parent. All right, now HK does tell me the vertex. So H is going to be my vertical translation. H is going to move it right or left by H, and K is going to move it. That's going to be my horizontal translation. It is going to move it up or down. Now remember, we investigated this. You guys determined all this, but I'm just formalizing it in this video. All right, so let's look at a method of solving using these graphing using these translations. So here's an example. So the first thing that I always like to do if I'm looking at something in vertex form is to identify my vertex. So my vertex in this case would be 0, 2. The A is 1, so I have no scale change to it. So it's not getting wider or narrower. It's just like the parent. This is just getting shifted up 2. I then like to think about the axis of symmetry. Remember, the axis of symmetry is a vertical line that goes right down the vertex. And its equation is x equal, because it's a vertical line, whatever the x coordinate of the vertex is. So x equals 0. So always like to determine that first. All right. Our parent graph, if we're going to use translations to graph, will always be y equals x squared. And I want to think carefully about the points that I would graph on that. So remember, we graphed them, -2, -1, 0, 1, and 2. And the y's that would come out would be 4, 1, 0, 1, and 4. All right, so what's the verbal description of what's happening to this graph? It's moving up 2 units. Okay, so if it's moving up 2 units, it's affecting the y. So one way to do this is to write a rule that you can apply to the parent function. Well, if you think about this, if this is moving up 2, the x's are not going to change, only the y's are going to change. So my x's will remain the same, but all of my y's I'm going to add 2, and that would be my rule, x, comma, y plus 2. All right, so I apply the translation to the graph. My x's don't change, so -2, -1, 0, 1, and 2. But all my y's over here, I'm going to add 2. So that's going to give me 6, 3, 2, 3, and 6. All right, I'm going to plot those points. So I'm actually going to move this down a little bit. I left these blank for you so that you could put your x-axis and y-axis anywhere you wanted. So I'm going to put one here and here. I'm going to carefully label them, x and y. All right, so I have -2, 6, -2, 1, 2, 3, 4, 5, 6, -1, 3, so 1, 2, 3, 0, 2, 1, 3, and 2, 6. And you're seeing the symmetry. I see the symmetry here and here in the table. But I see the symmetry in the graph because when I graph that, my beautiful parabola, you can see that if this is my axis of symmetry, my line going straight down, that every point on the left has a corresponding point on the right. And that is just the parent graph shifted up 2 units. All right, let's try another one. This time I gave you 2 translations. But again, first thing I'm going to do is identify my vertex, my H and K. All right, so 1, 5. Remember, it's change sign, keep sign. My axis of symmetry then would be a vertical line. So x equals the x coordinate of the vertex. So x equals 1. Again, my parent graph, I'm going to get really good at this. And I'm going to plot my points just so I have them. So -2, -1, 0, 1, and 2, and 4, 1, 0, 1, and 4. A verbal comparison to the parent would be that this is shifting to the right 1 and up 5. All right, so we have to determine what our rule that we're going to apply to the parent is. All right, so if this was going up 5, that means that's a horizontal change. So it's changing my y's. So all my y's are going to get moved up 5. But right, 1, 2 is going left, right. So that's a vertical change. That's going to affect my x. So that's going to give me x plus 1. So all my x's, I'm going to add 1. All my y's, I'm going to add 5. So one thing I like to think about just to help me remember what to do for my rule is that inside the function, so the function is the square. So inside the function changes the x. And outside the function, so this is outside the function, is going to change the y. So inside x, outside y. So that helps me write my rule. Now that rule I'm just going to apply to my parent graph. So all of my x's I'm going to add 1. So that's going to give me -1, 0, 1, 2, and 3. And all my y's I'm going to add 5. So that's going to give me 9, 6, 5, 6, and 9. Okay, so now I have to be careful here because not all those points are on my graph, depending on where I put my axis in. So I'm going to draw my axis in again, and I'm actually going to do this. I'm going to make this my x-axis and this my y-axis and see if that works for me. I'm going to label those points carefully. Now I could also change my scale if I wanted to. But I've got -1, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So -1, 9. 0, 6, 1, 2, 3, 4, 5, 6. 1, 5, which would be right here. 2, 6, and 3, 9. You can see that my parabola is kind of funny here. It's way up in that left corner. You know, you could have played around with this a little bit if you wanted to. Has my graph been shifted? My parent that has a vertex at 0, 0, has it been shifted to the right 1 and up 5? Yes, it has. Okay, we're going to do another one. All right. Now what did I do? I put a negative in front of the function. And remember I said I always want you to determine if my graph opens up or down. That negative is like a -1. That negative, A, reflects it over the x-axis. So that is a reflection. All right, my vertex doesn't change though. My vertex is still HK, so H and K, so -4, -1. My axis of symmetry, a vertical line going through the vertex, so x equals -4. My parent graph, y equals x squared. I'm going to do my points really quickly. -2, -1, 0, 1, and 2. And my y's 4, 1, 0, 1, and 4. Okay, so my verbal comparison. Now remember, we do our reflections before our translations. So verbally comparing this to the parent, this one is going to reflect over the x-axis. Some kids call it a flip, okay? It's going to be moving to the left 4 and down 1. All right, what rule are we going to apply to our parent? Okay, remember, inside the function affects x, outside y to help us. Inside the function is here. So I'm going to take all of my x's and I'm going to subtract 4. Okay, and all of my y's, I'm going to subtract 1, but this is actually being multiplied to my y's. So I'm going to do -y minus 1. Negative y minus 1. Okay, I'm going to come down a little bit, and let's see. I'm going to apply the rule to the parent. Negative 2 minus 4 gives me negative 6. Negative 1 gives me negative 5. 0 minus 4, negative 4. Negative 3, and negative 2. All right, all my y's. So I'm going to get negative 4 minus 1, which gives me negative 5. Negative 1 minus 1, which gives me negative 2. 0 minus 1 is going to give me negative 1. Negative 1 minus 1 gives me negative 2, and negative 4 minus 1 gives me negative 5. But again, you can see the symmetry in the table. All right, so now I'm going to plot those points. Now I want to have negative 6 on this graph. So I'm actually going to I'm going to move my graph like right here. Because it looks like, oops, that doesn't look so good. Let me move that over like that. Let's see if this works for me. Put it here because all of my graph points are negative. Okay, so negative 6, negative 5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Negative 5, negative 2. So 1, 2, 3, 4, 5, 1, 2. Negative 4, negative 1. Negative 3, negative 2. And negative 2, 5. And you can see my parabola. And if I think about my parent graph, did it get reflected over the x-axis? Yes. Did it get shifted to the left? 4 and down 1. Yes. So all of those things happened to my graph. Okay, guys, so I'm actually going to stop there for today because that's, I think, enough in terms of a video length for you. And we'll do the next 2 graphs. We'll do those two tomorrow because those are a little bit more challenging. But if at any point you feel like you need to rewatch this video, go ahead and do it. And again, this is just one way to do these types of graphs. We've spent some time looking at them, so this was more just a formal lesson on the graphing of a translation. All right, hope you have a great day.